Hi, my name is Emily Van Beveren, and me and my partner Jamie Fisher created a STEM lesson plan, and we titled that Engineering Environments. So we have math, science standards that are covered in this lesson. So the math standard is recognize and draw shapes having specified attributes such as a given number of angles or a given number of equal faces. Identify triangles, quadrilaterals, pentagons, hexagons, and cubes. The science standard is to develop a simple sketch, drawing, or physical model to illustrate how the shape of an object helps it function as needed to solve a given problem. The mathematical practices that are present in this lesson plan are to make sense of problems and persevere in solving them and use appropriate tools strategically.
For the objectives, by the end of the lesson, students will have an understanding of how to participate in the engineering design process, which is the science standard, to design and produce a functional supply organizer, and to collaborate with their peers and persevere through problem solving.
The anticipatory set for our lesson is to have students get into groups of 3 and read the book Wild Ideas, Let Nature Inspire Your Thinking by Ellen Kelsey. As students are reading this book, we want them to get together and answer some questions to get them thinking not only about the book, but about the activity they will be doing later. These problems could include what problems did the animals have to adapt to in the book? Do you think all animals solve problems? And have you ever had a problem you've had to solve before? And if so, how did you solve it? After groups are complete, have the class come together for a discussion about all of their answers and what they enjoyed about the book. Then explain what the lesson activity is going to be, what standards there are, goals, and objectives. Modeling and input. So this is to get students more excited and really start to get their ideas and thoughts towards the lesson. This is a great time to show pictures of animals adapting their environment to their needs. It's important to show different types of structures, animals, and adaptations. Point out the different aspects of their builds and what they use. So as you can see here, we have a woodpecker who created holes in a tree to store acorns, a squirrel building his nest with pine needles they found, and an ant hill where ants create different caverns and cavities and tunnels to grow their families and eat food, etc. Then we will have students look around their classroom and talk about different aspects of the organization of the classroom itself, such as the bookshelf, where they turn stuff in, and what they're made out of. Then from there, go on to explain that although we build different things from animals and out of different materials, we still engineer our environment to fit our needs just like the animals to the left do before. And next, we'll be introducing the STEAM challenge.
So for our STEAM challenge, it's the engineering environments. The teacher will say, in teams, you'll design and create a tabletop organizer inspired by insect home of your choice. The organizer will hold your table supplies such as crayons, pencils, and glue sticks. The supplies must be easily accessible and withstand everyday use. The teacher will say, followed by the criteria, which will have to be met. So one of them is the organizers must take inspiration from the animals' environments. They need to actually be able to use their organizers. The organizers may not interfere with anyone's ability to pay attention or to see in class. And then some specifications for how high and how big it can be. So it can't be any bigger than 60 centimeters around, and it can't be taller than 30 centimeters high. And it must include at least 2 defined shapes that they can explain why its characteristics and sides, lengths of sides, etc., will help the structure stand and be used.
All right, so for the design challenge, the students will be given glue, scissors, rulers, tapes, markers, and paper to create the design for their organizer and the actual final product. These are just the basic supplies. Any other supplies the students feel they will need to complete their build need to be found by them. They can be found at home, in the classroom, even things from outside. This aspect encourages students to reuse materials to create something new and allows them to get more in touch with the idea of animals using what is found around them in the environment to create buildings and things they need. So for instance, students could find cardboard or sticks or rocks, anything they think will be necessary for them to complete their project.
For the independent practices, which the students will be doing in groups, is they'll work in groups, and first they'll start out by planning and drawing out the original design plan. They have to figure out what shapes, sizes, and materials they'll need to create the best organizer for them. This is when the teacher will be walking around and kind of assessing how the groups are working together and how they're doing. The students also need to keep in mind that they need to use animal structures and adaptations in at least one portion of their design. And this is a good time for the teacher to go around and make sure that they are following the criteria for how big it can be and to not exceed the 60 centimeters by 30 centimeters.
For the closure, students will share orally in groups about their desk organizer, so they will present it to the rest of their class. They will share their original design plans, their prototype, and then talk about what they think they did well in the problem solving and something they could do better on next time. The teacher will wrap up the lesson by revisiting the learning objectives and relating this activity to real life. Have the students think about what they built, how they did it, and what they used. Then discuss how engineers build things every day that adapt our environment to better fit our needs and how they use math to do it. This connects this seemingly small project to the real world.
By the end of the lesson, the students will have engaged in the whole engineering design process. They'll have first defined a problem and identified the constraints. They'll have researched the problem. They'll have thought about the possible solutions. They'll collaborate with others and to come up with a plan. They'll create a prototype of their solution, put their creation to the test, and then communicated with others how theirs worked and how it might be improved.
For this lesson, we used Naturally Organized, written by Teach Engineering, to inspire and adapt it into our own lesson. If you would like to see the original lesson that we used to help build ours, it can be found at this link below. Thank you so much for listening to our lesson.